Okay, hi everyone. So today I'm going to present the uh holomorphic um universal coordinate space uh of the yeah uh it was a holomorphic coordinate map. Okay, so let me pull out the book here. So okay, okay. So I'm going to check that. Um, um, so we check that. Uh, so we check that uh, gamma itself, the gamma from C star is okay. So even by 3 perhaps to e to the to I c over n uh is a unique motion unique confirm that. Yeah. So it's definitely a homomorphism. Okay, because it's a collision of two homomorphisms. And then so why is it covering map? Because uh let's say if you take the space, let's say you take a point zeta naught here, yeah, so just arbitrary point. Okay. So then I think you use the same technique uh, that we discussed in the before. Yeah. So basically, yeah, you take the U to be the set um, where this is excluded, right? So you okay. Um, okay. So suppose that um, let me think. Um, okay. So basically, what you do is that you take the like uh you take the fundamental branch of the multi-value multi-function. Okay. Um, log of theta, sorry, theta back to log of theta over 2 pi. Okay. So then you get one theta log. Okay. So and then yeah, we construct the set u to be yeah, and that's copy down. Roll e to the 2 pi. Uh, okay, so this z now basically is the same like yeah, so basically we're just doing the same thing like we did before. Yeah, so here we are just doing the same thing as before. Okay. So rho e to the 2 pi I, 0 less than sorry, 0 less than rho less than infinity. And then we have the t is between this x naught minus a half. Not equal to. Okay. because we want it to be not touching. Okay. So yeah, so this uh sorry, equal to I. And yeah, so this could give you a neighborhood around the zeta naught. Yes. Okay. So and also okay, so what is the unit cover, right? So what is the unit cover set? Um so okay, so when you take the inverse, right? So when you take the inverse, let's see what we get. Um uh uh so we will take the inverse. Uh so what do you get? Um, okay. So uh okay, so it's um okay, so I think it's UN. Okay. So where it is equal to Z. Yeah, so UN is consists of the point of Z equal to x plus y, where is y is real, and then this x is between x naught. Um, so I think here it shouldn't be minus half. So, so the length should be what? So length should be uh okay. So here because you are mapping okay. So when you are mapping a half, then because the angle is divided by n, right? So yeah, so therefore you should multiply by m in order to get back to the same thing. So I think it should be minus m over 2 plus n and then um, x naught plus m over 2 plus x. Okay. Uh, okay. Wait. Okay. So I think this n should also be multiplied by uh m. Okay. Okay. So let's see. So if you plug in the okay, so if you plug in um so let's check this. Um so so if that n x um set gamma's so gamma of this un, then uh so this implies that x is equal to the uh e to the 2 pi c. Uh okay. Uh z over n for some maybe I will use letter theta. So then for some z which is equal to x plus pi y, uh where okay, so where this x, okay. Okay. So this x is between that, right? Um uh so where this x is between this one, the left bounds, sorry, the lower bounds and the upper bounds. Okay. Um, okay. So, um, okay. So I think the key is part is that okay. So when you take the exponential of okay. So when you divide the whole thing by f, right? Uh, when you divide the whole thing by n, wait, let's see. So when you divide the whole thing by n, um, I think I need to rescale it by n. Yeah. So okay. So when you divide by n, um, sorry. So this implies that so so n is less than okay. So this implies that okay. So when you are taking the exponentials, that becomes uh uh to the super high of um x over n. Okay, so this guy uh oh okay okay yeah. You just think of it x over n as the t, okay. And then uh okay. Okay. So this implies that um I x over n is equal to equal to I uh x over s minus n where uh this guy uh is is within the set. Okay. Wait. Okay. Okay. So now, um, uh, yeah, and also the role is like, uh, yeah. So this role is trivially satisfied by the, you just expand the y part. Okay. You get the role. Yeah. So like that. Um, zero at infinity and t is between and then this t is between x not less than half less than x less than so that uh y is nice in u. Okay. Yeah, so for this one, for this row, right? So we can easily find a pre-image uh that corresponds to the y value here. Okay. So I will prove it. Okay, so now what about the t? Right. So for the t, so let's claim that um so now that uh so let the let x be equal to um okay, so here you want is that you want to plus n and multiply by m, right? Yes. Yeah, and then it's easy. Yeah, and then you show that after you do that, then um this x is between because you add n, right? Sorry, minus and half of n, and then everything multiplied by m. So you get exactly that. Then with the property that um, uh, so then it's easy for you to check. Let's check that e to the two pi I. Uh, so because we just ignore the y part, okay, we just focus on the x part. So e to the 2 pi I x over m. So e to the 2 pi x over m is exactly e to the 2 pi I t plus n, right? Which is exactly the same as e to the 2 pi I t. Okay. Because this n is just some, yeah, integer. Okay. Okay. So this shows that this just implies that theta is okay. Okay. Yeah. So we show that. All right. So um okay. So then it's a universal coordinate. It's also holomorphic. Okay. Okay. All right. So yeah, actually, I think I forgot to mention. So I think this map is actually locally holomorphic, and so yeah, so this is actually the chart that um yeah, and then this is actually a uh wait uh yeah, so this is a uh okay, so this is a projection. Okay, projection with the uh inverse by the holomorphic branch of the natural law composed with the uh v over m. Okay, so yeah, sorry, the natural law over 2 pi. So yeah, so therefore it is a uh so if you compose the uh, law it's theta over 2 pi. So this is the uh branch of the So then do the add, right? Yeah. So basically, if you take the uh inverse of it, okay. So you take the I think you just multiply by n. Sorry. Yeah. So basically, if you take the exponential of this guy, uh, okay. So then, yeah, you get back to the same thing. Okay. Um, into the two pi I over n. Two, two pi I. Okay. Yes. Okay. Um, so, oh, shoot. Okay. Um, okay. So therefore, this is the inverse of the exponential math. Um, under the uh, under the uh, uh, yeah, this is the inverse of exponential math. Uh, for any zeta in this U, yes. And then okay, and then by picking the branches, right? Uh, can also show that it uh lies in one of these sets. Um, um, So yeah, but um, because I remember that was a legend log, right? So if you have that legend log with zeta, um, it give you the so it is equal to the so let's say zeta is equal to the real part of if you take the log of the real part plus the uh pi times the angle um of this zeta, but yeah, I think constant number, right? Um, so actually, let me uh recall the definition of the natural law. Oh shoot. Yes. So here, okay. So here, this should be the modulus of the zeta. Yeah. Yeah, plus I, the argument of zeta. Um, Yeah, I think it's time. Let me check. Yeah, because if you take the exponential of this one, then uh you should get uh yeah, so this is the real part. Then equal the real part, which is uh the rho and also just the modulus of theta, then times e to the this guy. Yes, where the angle is like this angle plus n times 2 pi. Yes, it should do the same. Yes. I to the this angle plus. Okay. Yes. So yeah, it should be n times 2 pi. Oh. And also okay, so then you just take to be this graph. Okay. And then you oh okay. So you show that okay. So you show that um yeah, yeah, so you show that this could be uh yeah, so you show that this image actually lies in the um because um because if you take the exponential of this one, right? So the real part actually is the module of theta. So so wait, is it uh oh wait, no, wait. You take the exponential of this. Oh, sorry. Yeah. If you take the natural log, yeah, the real log, yeah, you get everything. Okay. Because you can just modify the modules of theta so that we just expand the whole like vertical axis. Okay. And then for this part, right? So for this part, so basically, um, so so this is it. So this argument you can take it to be just the uh yeah, so this is like between 0 and 2 pi, right? And then you plus another n copies of 2 pi. So then this lies in uh n copies of um wait. I think you divide by 2 pi, right? If you take the natural log. Uh so so what do I want to show? So I want to show that if you pick any if you pick the branch to be that guy, and then this image will get you the UN, right? Okay, so why? Okay, so if you okay, oh, okay, so yeah, so this is supposed to be your x. Okay, so this is supposed to be your x, and then this is supposed to be your uh imaginary part, right? Uh, yes, this should be the imaginary parts. Yeah, right. So after we divide by I, so then this becomes the imaginary part. This becomes the real part. Okay. So now for the real part, okay. So after you divide by I, and then you multiply by wait, hold on. Okay, I think there's an issue about the scale. Uh, okay. So if you divide by two pi I here, this argument is divided by two pi. Okay, so meaning that this guy actually stays inside the uh okay. Yeah, so once you divide by 2 pi, so then uh depends on how you view it, right? Okay. So but it's actually a rescaling. Okay. So you can see it as like a move from like letting one half to one half. Okay. And then after divided by 2 pi I, so then this becomes just n, right? And then okay, so wait, so let's see. Theta. So let's forget about this one. Okay. So let's just focus on the uh imaginary parts. Uh, uh, to, uh, So so why it lets me do that? So why it lets me do that? So uh okay, so because if you multiply by I and then yeah, so okay, yes. So if you multiply everything okay, what do you want to say? So yeah, so if you multiply by m to everything here, okay, so okay, so yeah, so if you multiply by m, okay, so yeah, yeah, so yeah, yeah. So basically, the idea is that we because we just focus on the angle part, okay. So you just replace the angle part. We just replace the log theta by this uh angle part, okay. So basically, if you multiply by m to everything, then and then divided by two pi I, so then you will get uh exactly this term plus mn, okay. Yeah. So and then this guy we know that it's gonna be that. And then if we just add like mn on each side, and then yeah, so this is exactly the angle part of this whole thing. And then this is actually exactly bounded by uh the by the same bands. So therefore this shows that if you input any data for zetas for the data that's inside this U. Okay, so therefore you can always the image will always lies in that by the according to this method. And then you also show that this uh so this defines a map from U is it onto? I think it's also onto, right? Yes, I think it's also onto. So and also uh yeah, so that shows it's a bijection. Okay, so it's a holomorphic, it's a biholomorphism. Okay, yeah, that completes the proof that it's a local uh biholomorphism. Okay. Okay, so let's just end here and then we'll continue next time. Thanks.